This is Liliana Beltran from the Department of Architecture at Texas A&M University. I will present a study that demonstrates that it is possible to achieve the 3 points of daylight credits of LEED version 4 in all latitudes and orientations. This table shows the LEED version 4 metrics evolution from 2014 to 2019. In 2012, the Illuminating Engineering Society released the LM8312 method for Spatial Daylight Autonomy (SDA) and Annual Sunlight Exposure (ASE) metrics. In 2014, LEED adopted the use of SDA and ASE. The credit requires a minimum of 300 lux for SDA for at least 50% of total occupied hours of the year, for 75% or more the occupied floor area, and no more than 10% of regularly occupied spaces can exceed 1,000 lux of direct sunlight for more than 250 hours per year, for 3 LEED credits. These are the 12 locations of this study. They represent a wide variety of climates from hot and humid to cold and snowy, and from very sunny, like Phoenix, to overcast skies in Anchorage. In this study, latitudes from 0 to 25 are considered low, from 26 to 50 are considered intermediate, and over 50 are considered high. The LM8312 standard was developed for latitudes 37 to 47. These are the annual incident solar radiation over a sky dome for low, intermediate, and high latitudes. The Ladybug tools were used to design the shading devices for all the locations and facade orientations based on annual solar radiation. A typical office space with their vertical facades facing the cardinal directions was modeled in Rhino 6 and linked to a grasshopper and Diva for Rhino script. The design variables were window size, geometry, and optical properties of the shading devices. About half of the simulations were conducted manually using principles of effective shading design. The other half used a parametric approach. This slide shows the south-facing facade that achieved SDA over 75% and ASC under 10%. The responses were different for the other facade orientations. These slides present a summary of the window-wall ratio and reflectances used in the shading devices by latitude and orientation. To achieve SDA over 75%, the size of the windows was increased from low latitudes to high latitudes. North and south orientations had the smallest windows. In most cases, the window size in the east and west facing orientations had medium-sized windows, except in high latitudes. South and west facing facade used mostly 70% reflectance in low and intermediate latitudes, but up to 90% in high latitudes. The only facades that needed a specular reflector to pass the SDA above 75% requirement were the east and west facades in Anchorage. This slide depicts a summary of the SDA and ASC results. SDA above 75% was achieved in all latitudes and orientation, even though the annual incident daylight varied from 26 to the 10 to the 6 lux hours in Anchorage, north facade, to 138 times 10 to the 6 lux hours in Phoenix, south facade. The locations that achieve 100% SDA are highlighted in red. The lowest ASC values, almost zero, highlighted in blue, are reached in intermediate and high latitudes in north facade. In all other locations and orientations, the ASC values were under 10%. This is a summary of the SDA and ASC distribution at low, medium, and high latitudes. Quito has the highest and most uniform SDA distribution in the north and south-facing facades, and receives the lowest SDA in the east and west-facing facades. The lowest ASC values are achieved in the intermediate and high latitudes of the north-facing facade. All the other facades receive 1,000 lux for more than 250 hours in areas adjacent to the window walls, except for the east-facing facades in Phoenix. The projection factor shows to what extent a window is blocked from daylight by external shading. Hence, the higher the PF, the lower the SDA and ASC. It is noticeable that projection factor for south-facing facades increase with the latitude. South-facing facades in low-latitude location require minimum shading devices to comply with the SDA and ASC metrics. Intermediate latitudes require extended shading, and high latitudes require shading that extensively block the window glass. This study demonstrates that it is possible to achieve the 3 points of the LEED version 4 daylight credits for north, south, east, and west-facing facades at locations within latitude 0 to 62. Although the SDA and ASC metrics were developed using spaces located in latitudes 37 to 47, these metrics can be used in any latitude and in all orientations. Shading devices and windows have to be designed according to the requirements of solar geometry by orientation and weather conditions. South-facing facades require minimum shading in low latitudes, extended shading in intermediate latitudes, and shading that extensively blocks the glass in high latitudes. North-facing facades do not require shading except at equatorial locations. By removing the ASC requirement and giving points to SDA 300 to 40% of the space, the new LEED version 4.1 promotes the use of large expanses of glass and does not encourage designers to harvest daylight. The design of effective shading device for windows requires a good understanding of solar geometry, local climate, building orientation, and development of articulated facades that integrate shading devices, reflector, view windows, and adequate window areas. Thank you.